So let's talk through the Big Bang. And what do we know about the Big Bang? What do we know about the beginning of all of space and all of time? And I still find it fascinating that we know a lot about this. Now, first off, of course, not this Big Bang Theory. And the concept of Big Bang Theory is out there in public culture. Some of you may have read the books, The Hitchhiker's Guide to the Galaxy, and I like this. In the beginning, the universe was created. This made a lot of people very angry and has been widely regarded as a bad move. Then there's this poster, Big Bang Theory. In the beginning, there was nothing which exploded. That's not exactly true, but we'll talk about that. The authors of our textbook have a quote that I absolutely love, and they say, "It's easier to predict the properties of the early universe than it is to predict the weather." And so many people look at me with this puzzled look on their face and say, "You got to be kidding. How can they predict the early universe?" Well, the weather is very, very complicated. You have lots of different air masses, and you have lots of terrain and moisture and a whole bunch of different things going in. The early universe was quite simple in a lot of ways, and we can predict the early universe using our scientific theories, and our scientific theories must be testable with experiments, and they must not violate laws of mathematics. So mathematically, scientists can recreate how hot did it have to be at the early universe, how dense did it have to be at the early universe, and then we recreate those conditions to the best of our ability in machines like particle accelerators. And by doing that, we can test if our thoughts about the early universe are actually true. Now, what a particle accelerator does, and this is the CERN Large Hadron Collider that actually exists in Switzerland. This is a huge underground ring, and the reason it's underground is because it does emit some radiation. And what they do is put in little subatomic particles like protons. They accelerate them really, 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 really crazy, crazy fast, and then they smash them into each other in a contraption like this, so that all of this whole big ring around here is a collection of sensors. And in a three-dimensional picture, they record all of the tracks of the particles that come out when they push things together, little subatomic particles, really, really fast. Well, by interpreting these tracks, they can look at how hot they are, what new particles are produced, what kind of things occur when you get densities and temperatures like the beginning of space and time. In particle accelerators, we can achieve temperatures and pressures similar to what our universe was like 1 × 10⁻12 seconds after its birth. That, ladies and gentlemen, is amazing to me. That is a huge, beautiful thing that we can actually test in a small scale, of course, what our universe looked like when it was so young. The other thing we can look at is the Big Bang predicts expansion, and the Planck map and the W map are evidence that the energy went from a little tiny nugget to this huge expanding energy ball that is our universe today. It's just like that puddle analogy where we had that little cup of water and then it gets spewed over a big puddle, and how did that water and that heat get distributed? So how did the Big Bang begin? Something happened. In the beginning, something happened. What exactly occurred at that instant to start the universe? We're not 100% sure. It is believed that the beginning of the universe was a singularity. Now that is a point that is infinitely hot and infinitely dense. So small that it has no dimensions. It has no length, width, height, or size, but uniform in density and temperature. What happened to create the Big Bang? There's a whole bunch of theories. One theory is the parallel universe theory, that you and I are on one universe and there is another universe next to us, and that perhaps what created the Big Bang is that these universes are not flat. They can warp and twist, that maybe one touched another one, and that was such a huge influx of energy that it created the Big Bang. Another theory of what created the Big Bang is the concept that perhaps it was a black hole that pierced through one universe and touched another universe. The honest truth is we don't have an answer for this yet. What was there before there was the space and time that we know of? And that's kind of like asking what is north of the North Pole, Stephen Hawking said. It is a totally different set of coordinates and kind of unaskable at this point in our history. Maybe before we are all old and dead, they'll have a much better answer for that. So the earliest time that we kind of have a clue about is 1 times 10 to the negative 43 seconds after the Big Bang. The earliest moment that we can know anything about is referred to as the Planck wall. Max Planck was a physicist, and using some of his early works and these concepts of black body radiation, etc., it is believed that we just will never know what happened before 1 times 10 to the negative 43 seconds after the Big Bang. So there's just no way for us to gather information prior to that, because you have to have particles or light or something as an indicator of what happened. So the fact that we can know so close to the beginning, again, pretty nifty. At about 1 times 10 to the negative 37 seconds after the universe began, it was very hot and very dense. And as it begins to expand, it begins to cool. So the whole universe starts from a tiny, immeasurably small spot, and it grows. And as it grows, it cools off. Sort of, again, back to that puddle analogy, if you take the same amount of heat and you smear it over a bigger space, the whole space is going to be colder than when the heat was at one chunky little nugget. Beginning of the universe, we think the temperature of everything was 10 to the 32nd Kelvin. That's incredibly nutty hot. At about time is 1 times 10 to the negative 32 seconds. Mathematically, our theories say that the universe will expand into about the size of a softball. That tiny little expansion from a singularity to the size of a softball, that softball universe, just expanding that heat out that much has cooled it down to 10 to the 27th Kelvin. So it's expanding like a hot air balloon, just blowing up with heat. At time is 10 to the negative 12 seconds, the temperature dropped to about 10 to the 15th Kelvin. This was hot enough for the first particles to be produced. And when we say particles, we're talking electrons, protons, etc. But it was still too hot for protons and neutrons. So we had electrons, and we had other weird things called quarks. And we'll talk about quarks in the next video. How do you get particles produced just because the universe cools? Well, that goes back to E equals mc squared. Energy can manifest or change into pure matter. And from some sort of another dimension, energy spews forth and kind of crystallizes, sort of like water vapor can crystallize into ice crystals or snow crystals. We think that energy can crystallize into matter as the universe cooled. All right, we will come back next time and continue with more on the Big Bang.